So we have finished vector, and yesterday volume of parallelepiped we have finished, that is A dot C. Clear? So I think you have no doubt in this topic till vector. Now we will start. Now introduction to vector and forces we have finished vector. Clear? Now we will start forces, means we will start our mechanics. In this entire mechanics, you will learn a lot of things. And sidely, I will share some DPP so that you have more practice. Clear? So let's start the discussion. First, write down this chapter is simply forces. In the vector we have finished. Now we have started forces. Mechanics we have started now. So write down first what is the mean gravitational force. First we will learn what is gravitational force. Gravitational force. Okay. So first we will learn what is the meaning of mass. What is mass? So write down the definition of mass. It is a property of, it is the property of a body. Mass is a property of body which is proportional to, which is proportional proportional to quantity of matter. Quantity of matter. So more the quantity of matter, more is the mass. So it is a property of body which is proportional to the quantity of matter. You know what is matter? Matter is anything which occupies space and have mass. You see, anything which occupies space is known as matter. Like we all human beings, table, chair, pen, pencil, all the living and non-living things, entire universe has some matter. Okay, so it is a property of body which is proportional to the quantity of matter. In my body, matter is different. In your body, different matter. So everyone has different mass. Clear? Now moving to the next, what is inertial mass? Write down the heading. Next is inertial mass. Inertial mass. Write down the definition. It is the mass by which, it is a mass by which body opposes the change in velocity. Opposes the change in velocity change in velocity to make the body stable. To make the body stable. So it is a mass by which body opposes the change in velocity to make the body stable. Inertial mass. Inertia means which restrict or which oppose the change in a state. Simple. The mass which will oppose, which will restrict the change in a state, it is known as inertial mass. You know, in our body, our mass whenever we are running very very fast, then after some time, because of our mass, we are stable. Okay, our velocity is going to decrease or change. Who is opposing like a change in velocity? The inertial mass. Clear? For example, the football ball. Football, you are having football, you are kicking the football. One football is made up of stone, one football is made up of foam. Then in which football has more inertia? Stone. Okay, stone football, the football made up of stone has more ability to oppose its state, which oppose the change in velocity. It has more opposition ability. Okay, so if it has having more like opposition to more resistance to change in the state, it means it has more stability. Okay, you are applying same force on two bodies, but one body has less inertia, one body has more inertia. Then which body is more stable?
It
With
has
more
more energy.
inertia, because it has more ability to oppose its change in velocity. Okay, that's why it is opposing to make the body stable. Okay, so inertial mass is clear to you.
Yes,
In
sir.
our body, like our skin, that is like inside that muscles, these are mass. Okay, understood?
Yes, sir.
After this, write down gravitational mass. Gravitational mass. Gravitational mass. What is that? Write down. It is a mass by which one. It is a mass by which body attract another mass. Okay. So we are having two mass, for example. Have you written?
Yes, sir, I wrote it.
So gravitational mass is the mass by which one body is going to attract another body. The mass which is responsible for attracting another mass. Okay. Like in gravitational force, one mass is going to attract another mass with a certain force, that is known as force of gravitation. So the mass which is going to because of that mass, there is some gravitational force of attraction. That mass is known as gravitational mass. It is a mass by which body and a body attract another mass. If there is no mass, then how it will attract? Okay. If you are having two bodies, one body is having m1 mass, one body is having m2 mass, then they are attracting each other with a certain force. That is known as force of gravitation. Now we will learn, write down the heading, laws of gravity. Laws of gravity. Clear? Write down, it states that it states that every mass, every mass, every mass attract another mass body. Every mass attract another mass body. It states that every mass attract another mass body with a force F is equal to G m1 m2 by r square. Every mass attract another mass body with a force F is equal to G m1 m2 by r square. You know that. What is G? G is a universal gravitation constant. M1 is m1 and m2 are the gravitational mass. So m1 comma m2. What are these? These are the gravitational mass. Gravitational mass. Clear? What is G? Universal gravitation constant. Universal gravitational constant. Okay. What is its value? Its value is 6.67 multiply 10 to the power minus 11. Okay. Unit is Newton meter square per kg square. Now this formula which I have involved, like what is R? This is one body and second body. They are very, very far. Not distance. Okay. This body is having m1 mass. It is having m2 mass. They are far away. Now this body has a center this. This is the center of this body. This body has a center this. So R is a center to center distance. Okay. This is center of this body. Let us suppose C1. Here center C2. If you join these two center, you will get this line. This force will be acting along this line only. This is R. R is the center to center distance. Center to center distance. Okay. M1, M2 is clear. Now this force is a central force. Write down, note. It is a central force. It is a central force that acts along the line joining the centers. Okay. So the line which is joining the center is where is that line? This is a line. Okay. Along this. Now you please tell me this M2. This M2 will attract this M1 in which direction? This M2 will attract this M1 in which direction? Like this. Okay, it will apply force like this. Similarly, M1 will attract this M2 like this. Okay, then I will write here in what we write. Let's see, F1, force acting on 1 due to 2. F12. Clear? Similarly, write a vector sign also. This is F21. Force acting on second body due to 1, like this, you write. And remember, this is a line joining center to center line. It always act along the line joining the center. This is a line joining the centers. Clear?
Sir, this force, sir, I thought this was supposed to act on 2 due to 1, sir.
What?
The initial force, I thought it was supposed to act on 2 due to 1. This side.
Initial F12 means like M2 will attract this M1 like this. Force acting on first body due to second body. F21 means this M1 will attract this body like this. Now attracting in nature, they will attract like each other. Like this. Okay, it has, you can write note, one note. Write down. It has one more note. Write second point in note. Its nature is attractive. Its nature is attractive. Okay. Now write important like why, where it is valid. It is valid for point mass. First, point mass. Second, spherical body. Spherical body. Okay. It is valid for point mass and spherical body. And how will you understand like what is the meaning of point mass? Point mass, for example, sun and earth. Can we apply this on sun and earth? Yes, because sun is quite far from the earth. Then both are point mass with respect to each other. If two bodies are far away, like for a star is point mass. Because you are like aeroplane when it is flying in the sky, then aeroplane is point mass for us. So when the separation is very very far, when the separation is very very large, then we can consider a body to be as point mass, then it is valid for that. Okay. And a spherical body, it is easily applied, but remember one thing, it should be point mass, valid point. Okay. Now how will you consider like this body has a point mass? Just write down. For example, this is m1 and this is m2, and the separation between there, how much? 1 meter. If the side length of this m1 is 10 centimeter, its size is 10 centimeter. Share here also. Now my question is, can we say it is a point mass? It is 10 centimeter. This is also 10 centimeter. Both are at a separation 1 meter. Then if you calculate percentage size, how to find? The size of a body, size divided by separation. Okay. Multiply 100. This is a formula. Percentage size. How to find whether it is point mass or not? This is the way. Size by separation. Clear? Size means like our earth. Earth size divided by, if you are interested like whether we should consider this body as point mass or not, then you will find first percentage size. That is size by separation. So in our case, like percentage size, how much it will be? What is the size of a body? 10 centimeter. In meter it will be like this. Divide by separation. Separation how much? 1 meter. Clear? Then how much it will be? 0.1. 0.1. Okay. Now 0.1 meter. 0.1 meter means how much? 0.1 percentage size. You just find like how much it is coming. 0.1 meter. 0.1 which is less than equal to 1. And if you multiply with 100, because it is 100 na percentage size. Okay. Then how much? 10%. Okay. In fraction 0.1. Okay. If percentage size in fraction, that is 0.1, if it is coming out less than equal to 1, okay, then we say it's the point mass. In fraction 0.1 or in like in percentage it will be 10%. If you multiply both sides by 100, then it should be like almost 10%. Clear?
Yes, sir.
So percentage size you should understand like a body may be consider, write down important note. Write down. A body may be considered a body may be considered as point size if its size is not given. If size is not given, we will consider it as a point size. Okay. If its size is not given. If its size is not given. Or if size is given, or percentage size percentage size is less than or equal to 1. Okay. Clear?
Yes, sir.
Percentage size in fraction I am talking about. Okay. Understood?
Yes, sir.
Any doubt?
What else,
Either
sir?
tell like it is like previous case, you can check. Size is how much? This is size of a body, 10 centimeter. Okay. So 10 centimeter by 1 meter. If you multiply by 100, then it will comes out to be how much? 10%. Okay. Either you say like 10% or you say fraction less than equal to 0.1. Clear?
Yes, sir.
Is this clear to you? Like when will you consider like it's a point size or point mass?
Yes, sir.
Clear? 1 minute. Please write. Have you written?
Yes, sir.
Okay. Now if I ask you one question like this is our earth, okay? And this is center of the earth, radius. If you kept an object having mass m, okay, this is the size of this body, let us suppose h. Okay, this is the size, and earth mass is let us suppose m. So my question is, what up to what size we can consider body to be as point size when it is placed on the earth? Look at here. What we have learned, like if I ask like here, how will you find percentage size? Size of this body is h divided by separation. Separation is how much?
R.
Center to center, na? This is our center of this. This is a block. This height is h. Its center will be lying along the at the center of mass. You will learn later. Its center will be lying here. It is how much? H by 2. You will learn later. Center of mass once I teach, na? Center to center. It is h by 2. Center of mass will be here. This is r from center of the earth. This total distance is r plus h by 2. Okay. Later you will learn, because center, how to find center, you are not familiar, but I am telling its center will be lying like this is a body, its center will be at their geometrical center will be the centroid, or we say center of mass in this case, symmetrical bodies. Okay, so its center of mass will
Yes.
be at x by 2. That you will learn later. Center of mass is a entire chapter. Okay, so no need to worry. So percentage size will upon separation. Separation is center to center. R plus h by 2. Multiply 100. What I say, it is either less in fraction less than equal to 1, or it is what? Less than equal
Equal
to
to 1.
in percentage na, like this. 10. Very good. Okay. Now can you please find the value of h in terms of r?
Yes, sir.
Find. Less than or equal to 1. 1 means what? Okay, sir. Okay, fine. Okay, we will understand like this. Okay.
Sir, I am able to find H
I
R
am
in
telling,
terms
I am
of H,
telling.
but
See, if it is, I am saying less than equal to 1 na, that is fraction value, but it is like 100. Is it so?
sir, how 100, sir?
See, I am telling like in our case, in the previous case, what answer we are getting? Like percentage size. Percentage size formula is size by separation multiply 100. Okay. So in our previous case, this cube is 10 centimeter. It is also 10 centimeter. It is placed 1 meter ahead, 1 meter at separation. Here. So here percentage size is what? 10 centimeter by separation. Separation is how much? 1 meter. Okay. Percentage, if you want percentage, then multiply by 100. Clear? Then it will be 10 by 100. It comes out to be how much? 10%. Clear? So at least 10%, if it is so na, 10%, 10% means it should not be like if it is in a percentage 10%, or we say 0.1. So a body can be considered as a point size if its size is not given, or its percentage size is less than or equal to 1. Okay, less than or equal to 1. So percentage size Condition is that if percentage size is less than equal to 1, this is a condition. So my question is size by separation. Let me check previous into 100. I'm checking the data, some data. Separation is there 1 meter, na? 100. The size will be how much? What is that? How much? 0.01 meter. Okay. Size, if size is less than or equal to 0.01 meter, or we say how much? 1 centimeter, then we say it is a point mass. Clear? In our case, in the previous case, is it less than? What is that? 10 centimeter. 10 centimeter is less than equal, less than that? No. Previous question little bit change. Do you please do the needful changes? Have you written this?
Yes, sir.
Okay, then no need to write this. First of all, let's cross this 1 minute. Little bit change. This is not okay. Don't write this. Why it is coming like 1 minute. You have written this percentage size, na? First of all,
Yes, sir.
up to this, right up to this only, it is valid for point mass spherical body. Up to this only, right? Don't write this entire thing currently. Do you write this up to this? Up to this, did you write?
Yes, yes, sir.
Okay. 1 minute. Important note, have you written like a body may be considered as a point size if its size is not given or its size is less than or equal to 1? Have you written this?
Yes, sir.
Okay. Size is not given, percentage size is less than or equal to 1. Now remember this, percentage size is less than or equal to 1. This is a condition for point mass. Okay. Maybe that question is wrong, which I have taken. Some data missing. Okay. That's why we are getting wrong result. Write that only. Now in our case, Earth, this is a Earth, and this is any body which is placed on the surface of the Earth, like this. This body having a mass, height is h, means size. The center of the Earth, radius, and this is the center of the this body, which is a h by 2. Okay. Then how much separation? Center to center, center of this body, center of the Earth. R plus,
R plus H by 2.
and this is our Earth mass. This is a body mass. Then I want to know up to what height we can say this is a point mass. Okay, so simple condition is that percentage size for point mass, percentage size must be less than equal to 1. Okay, percentage size is size by separation. Here size, or the size of how much size? H na?
H.
By separation, separation between center to center.
R
R plus
H by 2.
percentage, we need to multiply by 100. Okay, now as compared to R, as compared to R, this h by 2 is less because R is 6400 kilometer, and we can neglect. So we can write h by R is less than equal to 1 by 100. So here from here h must be less than equal to 64 kilometer. Clear? So what condition we found? If the height of a building or any body on the surface of the earth, if its height is less than or equal to 64 kilometer, then we can say it is a point mass. Okay, if it is 32 kilometer, with respect to earth, okay, with respect to earth, if the h, if the size is less than equal to 64 kilometer, we can consider this body as a point mass or point size. We can apply the like what? Like this laws of gravity. Okay. Like this you can find. Understood? Separation, size wise separation must be, percentage size must be less than equal to 1. Previous case, don't write those things because I have taken that question but some data is missing there. That is not 10 centimeter size. In previous question, that is not 10 centimeter. Condition for point mass is percentage size is less than or equal to 1. That is the condition only. And
Yes, sir.
percentage size for formula is size by separation multiply 100. Is it clear? Have you written that formula?
Yes, sir. I wrote it.
Okay, because it is very very important. And one more thing, like F is equal to G. If you know that, you can apply this formula. F is equal to G m1 m2 by r square. Okay, what is the separation in between this two body? R plus h1. You can apply this formula. F is equal to G m1 m2 by r square. You can apply here. Okay.
Yes, sir.
So this is, I think, clear to you, like gravitational mass, inertial mass, laws of gravity, and where we can apply percentage size must be less than equal to 1. It should be point mass. Clear? Next. Write down normal. What do you mean by normal? You know normal contact force?
Yes, sir.
Okay. Now write down. Whenever a body whenever a body comes in contact whenever a body comes in contact so write down, whenever a body comes in contact with another body, with another body, a normal is produced, comma, a normal is produced. So condition is when a body comes in contact with another body, a normal is produced. Value of normal, write down the next line. Value of normal is self-adjusting. Self-adjusting depending on the question. Okay. Okay. As per question, it will vary. Okay. Self-adjusting. Next, if Earth stop attracting, if Earth stops attracting object, then normal becomes zero. If Earth stop attracting, then it never comes in contact, and there is no normal. Then normal becomes zero. Normal becomes zero. Next, very important. Direction of normal. Direction of normal is always perpendicular to the force, but not perpendicular to the surface. perpendicular to the surface and has a tendency perpendicular to the surface and has a tendency to repel the body. Okay. Now look at here. So this is clear. Like, now understand how to apply the normal reaction for this is a floor. Okay. On this floor, if you place any object like this object is having the mass m. Now, which surface is in contact? See, this is the surface is in contact with the floor. This is first body, one body, this second body. Okay. Then second body is in contact with the first body. This is a contact surface. This is contact surface. Okay. So I will draw this contact surface separately. I will zoom it. This contact surface, now this is the surface in contact. You can check. This contact surface I have drawn here. Now I want to know the normal reaction force on this acting on this object. Now my system is this. This is my system. I want to know what is the direction of normal force on this. This block which is placed on the surface of the other object. Then this is my system, the block. Now on this block, the normal will be, direction of normal will be, who will apply? First surface. The first surface will repel in which direction? The direction of normal is what? Tell me, it is always perpendicular to the surface and has a tendency to repel the body. Now, first body will repel the second body in which direction?
Upwards.
Like this. Okay. The second body
Downwards.
Second body will repel the first body in which direction? Like this. I can write any.
So first body will repel second body like this, sir.
But I am asking only this first body. Na system I kept that. So normal will be like this. This is normal should be perpendicular to the surface. Okay. Similarly, if I kept first body as my system, then on first body, the second body will apply normal will be like this. Action reaction. Both are equal. Clear? Understood? Only
Yes,
normal I am talking. I'm not talking anything else. I'm talking about normal. Now you can see N1, N1. Why am I taking that? Because these are the action reaction pairs. If Earth is applying N1, then body will apply N1 on Earth. Like that. Understood?
Yes, sir.
So direction of normal has a tendency to repel the body. It has a tendency to repel the body. That's only. Now see, in this case, how will you draw the normal? This block is here. Okay. This the surface is in contact. So on this, it will be the normal. Okay. On this object, normal will be like this. If this is the case, there are two walls. These are the two walls. And one rod is there. Rod, or you can say like ladder. Okay. Now in this case, how will you find the normal? I'm telling. You just tell me like this surface is in contact. Okay, here. Now you just tell me if you look at only this contact surface, here the surface of wall is there, here surface of wall is there, and the surface of rod is only along one side. There is no surface of rod here. Okay. If you look at this surface is in contact, this surface is in contact. Now, if you see the right word, there is a wall. If you see here, there is a wall surface. These are the wall. This is wall. Okay. But for the rod, this is our rod. But for rod, we have surface on one side only. Here only. There is no surface here. Then in this case, normal will be perpendicular to what? The surface which will dominate. Which will dominate? Which is having more surface. Now it will be perpendicular to the what? Like this. Okay. This is a normal. Similarly, you can check. Here, this is surface in contact. Here, like this surface in contact. Here, wall is there. Left wall is there. Here, rod is there. But there is nothing here. Nothing is here. So there are two wall surface and only one rod surface nearby this contact surface. Then it will be perpendicular to the wall. Like this. It will be perpendicular to the wall. This is the normal. Clear? Understood?
Yes, sir.
Now, if I ask you like in this case, this is the case. If rod is placed like this, no. Tell me how to draw the normal here. In which direction? Here only. Tell me here. This surface is in contact. Clear? Can you please tell me like how to find the direction of normal here? If you look at this surface in contact, this red surface here, wall is there, here wall is there, here rod is there, left, but there is no rod here. Then it will be perpendicular to the wall. Okay, but here you can check. This is the surface is in contact. There is wall, no wall is here. Here, nearby this contact surface, there is rod, there is no rod. 50% chances. Okay, 50% chances means it is neither. It will be. We are not sure. To perpendicular, it will be perpendicular to which surface? Rod surface or wall surface? Here, because you can check now wall, this rod is at the corner. So we are not sure our normal will be perpendicular to the wall surface or rod surface. We are not sure. Then we will do what? We will take one normal in the right direction and one normal in the upward direction. If we are not sure, we will take in X or Y, two normal. Clear? These are the special case. Okay?
Yes, sir.
Understood?
Yes, sir.
Can you please draw the in this case? This wall M1. Okay, M2. Now, can you please tell me normal reaction force here?
One normal
This
in
is my
direction of
system.
M2, other in
This is my
direction of
system.
M1,
Very good.
upwards and downwards.
If this is my system only, then here normal will be due to ground. 1 and due to this contact surface. Okay, it will be like this. Is it so? Clear?
Yes, sir.
Then in the free body diagram, how will you show? This is N2 on M1 and 3 is like this. Clear?
Yes, sir.
Understood? So these are only two special cases which I have shown you. Now, can you please draw in this case? Normal, one block, M1, M2. Draw the normal direction. If it is my system, tell me.
M1 will act on M2 and M2 will act on M1.
On M2, this M1 surface will repel in this direction. N1, only this will act. Okay. If I take M1 as system, on M1, one ground will repel like this. This is M1. Okay. Is it okay?
Yes, sir.
Clear?
Sir, can you explain that again?
Very easy. Look at here, what I am saying. Look at here. This is M1. Okay, this is M2. Okay. So you please tell me, this is my system. Clear? Understood? So M2 will repel this M1 like this. Similarly, this is ground. Like this. Okay? Understood?
Right, sir.
What?
Right.
Your voice is not coming. Hello? Not audible. Hello?
Sir, am I audible?
Little bit like voice a little bit adapting. Yes, tell me.
Sir, M1 will also act on M2, right, sir?
N1 in the down, N2 is because of ground.
No,
N1
sir.
because
Normal from mass 1 will act on mass 2, right?
but I have taken, this is my system now. For this I have drawn.
Okay.
For that it is correct like N2 up. Okay. For only M2. Okay. Clear? Now in this case, N1 will be like this. Understood?
Yes, sir.
Okay. In case only one thing you need to learn. If wall is given, wall is there, and rod is placed. Rod is placed like this. This is a rod, okay? Rod. Then in this case, in the case of rod, always check which is dominating surface. This surface is in contact. Clear? If you look at carefully, nearby this contact surface, we have wall. Here also wall. Here rod, but there is no rod here. So which nearby this contact surface, which is having more surface? Wall only. So it will be perpendicular to the wall. You will take perpendicular to the wall. This is perpendicular to the wall. Because wall has two surface, more surface. Similarly here, you can check here also wall, here also wall. So don't do like this. Some students are doing what? You know what they are doing? They are taking normal like this. It is perpendicular to the rod like this. But it is wrong. Rod has only one surface. But wall has two surfaces. It will be perpendicular to the wall. This is the correct answer. It will be perpendicular to the wall. Don't take this. Okay.
Yes, sir.
I think it is more clear. And if this is the case, If case is this, like this, if case is like this, what is happening? If rod is like this, now here like this surface is in contact. Here two surface of rod, but only one wall surface. Then it will be perpendicular to the rod like this. Rod perpendicular to rod. Okay.
Yes,
But
sir.
in this case, the surface is in contact. Here wall surface. But here only one rod surface. There is no rod surface here. Nearby this. Then it will be perpendicular to the wall. Okay.
Yes,
Is it clear? So
yes,
normal
yes,
will
yes.
be perpendicular to the surface which will dominate. If 50-50% case like we are not sure which is having more surface, either rod or wall, then we will take two normal in one x or y. If we are not sure, even if you are not sure na, which if you are not understanding like which is having more surface, less surface, this concept, then always take normal in two direction. If it will be there, then it will come out to be well some value. If it is not there, it will be 0. Okay, clear?
Yes, sir.
Understood? Any doubt today lecture?
No doubt, sir.
Okay. Now second thing like what I'm asking like see if this is a rod, okay, and you are taking a nut bolt, not nut like what I say, you take a bolt and you fix it like this, okay, with the help of nut. Okay. Now here normal how will you take? You are not sure. Take two normal in two direction. One is like this and one is like this. Rod you just fix with the help of hammer this rod, then you are not sure whether you have to take normal. Okay. Then N1 in the right, N2 in the top. Okay. The bolt which you have fixed, it is in contact with the rod. There is normal. But where? We are not sure. Take N1 and N2 in two direction. If you are not sure, always take N1 and N2 in two direction. Okay.
Sir, here I don't know what the directions are, sir.
If you don't know, that's why I'm telling we are not sure. That's why we will take in two direction.
Sir, what are the two directions in this case, sir?
X or Y. Either in one in X, one in Y. Clear?
Yes, sir.
So this is clear to you. Our today's lecture normal and this percentage size which I have explained gravitational mass.
Yes,
And so today you just focus on
sir.
the direction of normal only. Direction of normal and percentage size gravitational mass. This is only focus. Your focus must be gravitational force and normal. Learn normal in depth. Okay. Now how to
Yes,
draw the normal? Please do the exercise. Again revise. SC Verma it is given this topic. Is check. Just read again.
yes, sir.
So I will stop. Thank you. Tomorrow I will start tension. Tension, how to find tension, what is the direction of tension, then spring force. Basic force we will learn. Clear?
Yes, sir.
Okay. Thank you. Balamika. Take care.
Thank you, sir.
Okay.